Hi everyone. In this video, we are going to discuss about regression. Regression, that is only linear regression we will talk about today. We will take only one independent variable and one dependent variable. In the next video, I'm going to discuss with you how we can calculate regression using Excel, multiple regression when there is only one dependent variable and number of independent variable. But in this example, I'm going to take one simple linear regression where is one dependent variable and one independent variable. I have taken there are the two variables. One is performance, another is size. Performance means that is the firm's performance. And size means firm size. Size in terms of the number of the employees. How we are going to measure size of that firm, that is based on number of employees. So firm's performance that depends on number of employees, number size of that particular firm. So performance in my case that is dependent variable and size is independent variable. So let me discuss one example. First of all, we understand regression analysis is used to assess the relationship between one dependent variable and several independent variable. When we are talk about this, that is multiple regression. When we will talk about here is not several, only one independent variable. So that will become simple linear regression. So here is regression coefficient. Definitely I'm going to discuss unstandardized coefficient, standard coefficient, that is beta value, R square, each and everything I'm going to discuss in this video. Adjusted R square, what do you mean by adjusted R square? What is the difference between R square and adjusted R square? That's the most important. I'm going to discuss all these. Multicollinearity, that is I had already created one independent video on multicollinearity and that is already available in my playlist. And types of multiple regression, also standard multiple regression, hierarchical, sequential regression, stepwise, all these regression I had already uploaded in my YouTube channel, and that is available in research methodology, statistical analysis. So this is the example that I would like to calculate regression in using Excel. Students want to test a hypothesis regarding the relationship between size and age of a firm and its performance in a particular industry. Size was measured by the number of employees working in the firm, age in terms of number of years it is operating, and performance was measured by return on equity. So 50 firms selected randomly. You can see here, these are the 50 firms I have taken into consideration. 50 firms, and here is, you can see here, this is the performance, size and age. But I am not considering in this example age of the firm. Means age means number of the years, how old that firm, that is 40 years old firm or 41 years old firm, is the 7 years old firm. I'm discussing only this one is the simple linear regression where is one dependent variable and one independent variable. Performance is my dependent variable that depends upon size. That depends on age also. When I'm going to consider both these parameters, both these variables, that will become multiple regression. But here I'm talking about simple linear regression. So size only I'm taking into consideration. Total number of firms you can see here, 50 firms, and hypothesis is already created. Firm's performance is not positively related to its size and age. That means we can say there is no association firm's performance and size and age. That means they are not related. But alternate hypothesis said firm's performance is positively related to size and firm's performance is positively related to its age. So I'm going to check only this part. It's related to its size. So these are the results of my SPSS analysis. Through SPSS, I had already calculated, I had already run this regression, and this is the hypothesis testing, right? These are the simple ordinary least square, all those things I had given. But now how we are going to start in Excel. So let me begin in Excel, the same data. So this is my Excel sheet, right? Performance and size. Now what we have to do? Everybody knows I had already explained you how come you have to use this data analysis tool. And data analysis tool, first of all, you have to go to file. You will go to options. And in options, you can see add-ins. This is one of the add-in that is given by Excel. And this add-in Excel add-ins, you have to press OK and you have to press this analysis tool pack, then press OK, right? And after that, you can see here in this data analysis tool pack would be available. So I'm going to calculate regression using this data analysis tool pack. So let me click here, this data analysis, and I'm going to use this not correlation. There is the one-term regression. You can see here that regression, and I'm going to press this regression. Okay. So now what we have to do in this regression, input range. Input range, because I want to check input range, Y range. Y is, here is, I'm going to mention this first of all. Here is, I'm just closing this. You can see here. Y means in regression, always we are talking about, here is, I'm putting all those things. Y means we are talking about independent variable. Dependent variable, right? And X means we are talking about independent variable. Independent variable. So now, what we will do, this would be the equation y equal to a plus Vx. So we just want to calculate, this is the regression equation. That is why we are using this data analysis regression tool pack. We just want to check. So y is our dependent variable and x is independent variable. In my case, this performance is y. So there would not be any confusion. And size would be your x. So that is my independent variable. And n number of independent variable when I'm going to use, that will become multiple regression. So first of all, what we have to do, data analysis, then after this regression, press OK. Input range, Y range. So I am going to select this. This is my Y range. This is my dependent variable. So I had selected. After that, it is asking input X range. So I'm going to select, this is my independent variable. So I have selected this. Levels. Yes, of course, because I have taken levels into consideration. Confidence level. By default, it is 95%. If it is 95%, that's all right. If you're using some other confidence level, so you have to check this. But I'm not clicking this because I'm using by default 95% confidence level. Now the output range. Output range, we can take it, output range, new worksheet. Here is the output range when you are going to decide here only, on this sheet only. That is already I have taken some results here. Or new worksheet, that means when you are going to select, so that would be a new adjacent work Excel sheet will open and results would be reflected over there. Residuals. You require residuals, you require residual plots, you require standardized residuals, you require line fit plot, and you require normal probability plots also, and press OK. Regression having trouble to offset input-output references. What happened? Okay, fine. Input-output range, that is change actually when I was showing. So now you can see Y range. Once again, we can select it. This is our Y range. And this is our X range. Let me select my X range also. This is my X range. This is my X range. And you can check this, right? So this is my, you can see here, uh, all these three plots that I require. This is the summary of the output. You can see. So now one by one, we are going to discuss this summary. One by one, we are going to discuss all those things. And everything, all the results are here. And after that, what we have to do, let me split all these curves also. Then you could be able to see all these curves. The next curve, because whatever the curves we required, all three curves that is visible here. Now, let me give you interpretation of this, because I had selected a new sheet. So this is the new sheet you can see here. And now interpret of all these results. Multiple R, you can see the same results I have got 0.3492 and same result multiple R. Multiple R means nothing. That is simply a Pearson correlation coefficient that I had already done in my previous video. So that one is the same. That is the simple Pearson correlation in between both these variables. R square. R square is 0.11. R square means coefficient of determination. It is simply multiple R square, and R squared measures the proportion of the variation in your dependent variable explained by your independent variables for a linear regression. So R square means simply it is a coefficient of determination. That means how much independent variable is explained is explaining your dependent variable. That means if this is the 0.11, so let me take 0.11 and it would be multiplied by 100 and equal to, that would be 11%. So that means we can say only 11% this size is going to explain, right, this dependent variable. Performance is dependent on this independent variable, only 11%. Then the adjusted R square. Adjusted R square is the better model when you compare model that have a different amount of variables. The logic behind is that R square always increases when the number of the variable increases, meaning that here is, you can see here, if we would add on number of variables, R square is going to increase. But in the adjusted R square, that is rationally would select what is the contribution by each and every variable. If suppose that particular variable that you had add on in your multiple regression that is not contributing a single percent, that means 0%. So adjusted R square, it will not consider that particular independent variable. So always you can see this adjusted R square always would be less than R square. Up now, most important question, which one is most important? So I would say adjusted R square is most important as comparatively to the R square. Why? Because adjusted R square, that will give clear picture, only those variables are relevant, those are able to explain this particular dependent variable, that will keep into consideration. Standard error. Standard error means we are talking about standard error of the regression is the average distance that the observed value fall from regression line. Smaller the regression means more accurate results. Means this standard error should be lesser. That means you are reaching towards the more accurate results. If you're not, that is bigger. So that means your result is not precise. Observations means total number of samples you have taken. In my case, if I had already explained you, only 50 firms data I have taken into consideration. So that is my observation. So I hope this video is helpful to you. And in the next video, I'm going to explain you other things, ANOVA. This table also I'm going to explain you, and all these three kinds of curves also I'm going to explain. So this p-value also, F statistics also. What do you mean by this F statistics? Each and everything. Thank you. Keep watching. Stay tuned.